Let's see who is here for the first slot. Márton is a Kotlin developer advocate at JetBrains, working on making Kotlin Multiplatform awesome. Passionate about education, he's guest lecturer at the Budapest University of Technology and Economics. He has been contributing to the community through writing, speaking, and open source libraries since his university days. He is a Google developer expert for Android and Kotlin, and the co-organizer of Android Budapest and Android Worldwide. When I asked him the question, what is the golden nugget for the audience throughout his career, he said, master your tools. So please welcome with a warm applause our first speaker, Márton Braun, with Build a Multi-Platform Future with Kotlin.
Thank you. I'll wait for a second to grab my slides here. There we go. Thank you. Hello, everyone. My name is Márton. I'm a developer advocate at JetBrains, and today I'm here to talk about Kotlin Multiplatform. Just to get a bit of a feel for the room and the audience, who here has used Kotlin before? Quite a few people. Heard of Kotlin? Used a JetBrains product? All right. So Kotlin Multiplatform is a technology by JetBrains which allows you to write Kotlin code once and then compile it to a bunch of different platforms, and therefore share code in Kotlin that way. For example, you can target the server-side, iOS, Android, desktop, and web applications using this. And if you're doing this on the client side, you can share not only business logic and data handling, but you can also optionally share UI as well. As you'll see throughout the talk, Kotlin Multiplatform is a flexible technology, so it's up to you to decide what you want to share and what you want to implement per platform. Now, there is a frequent debate between native and cross-platform development, right? With native, you can usually get the best user experience. You can use the built-in UI components of the platform so that apps behave exactly how users expect on the given platform. You get full access to all of the capabilities of the platform, whether that's background work, notifications, data storage, and so on. And of course, you get great performance because you're running the application on the runtime that the platform wants you to use. On the other hand, the cross-platform is also attractive in many cases because you can reduce your development time by not duplicating the same implementation on multiple platforms in multiple languages. And it also can ensure that you have consistent behavior and fewer bugs in your applications. And of course, once you do find bugs, you only have to fix them once because you have one shared code base. And as you'll hopefully see here, with Kotlin Multiplatform, these lines between the two things are blurred. So with Kotlin, you don't have to make this big decision of whether you're going native or cross-platform. You get to reap the benefits of both approaches, and you get to decide which part of your apps, again, you do share and what you implement per platform. Of course, you want to know that you're not alone in using a technology like this. Kotlin Multiplatform is already stable and production-ready. And there are a lot of different case studies on our website that you can check out of companies already successfully using it in production. So with that intro, a bit of agenda for what I'm going to go through during this talk. First, we'll take a look at the history of Kotlin and KMP and how all of its target platforms evolved over time. Then we'll take a look at how it works, how you actually organize your code when you're using KMP. We'll take a look at UI sharing. We'll take a look at the ecosystem that exists around the technology. And finally, of course, we have to talk about tooling. Starting with the history then. I have to go back all the way to 2010 here for the beginning of Kotlin's history, at which point JetBrains existed for about a decade, and this is what our website looked like. So we already had great products like IntelliJ IDEA, a bunch of other IDEs built on the same platform like PHP Storm, WebStorm, and so on, and also some theme tools. And the IntelliJ platform and IntelliJ IDEA product were all a large code base built in Java. And engineers at the time were looking for a better replacement for Java. They looked at all the available JVM languages that they could use, and they didn't find one that would suit their needs and their use cases. And this is how they decided to start the Kotlin project, called JetLang initially, internally, and develop their own language, which is generally not a great idea. Like, you don't want to arrive to a conclusion that you should build your own language. But here, there was sufficient expertise across all of these IDEs and product teams of working with a lot of different languages and creating tooling for a lot of different languages. So this was actually a really great place for a new language to get started. As I said, there was a huge existing Java code base. So Kotlin was initially developed as a JVM language, which could very smoothly interoperate with Java. You could call back and forth between Kotlin and Java without having to do anything special, like build headers or mappings or anything like that. And just like Java compiles directly to Java bytecode to run on the JVM, Kotlin has initially also compiled to Java bytecode directly. A year later, Kotlin was announced publicly, and a year later again, it was made open source, and it is open source to this day. It got to the 1.0 status in 2016, when basically the language has stabilized after about like 6 years of evolution. And after this is when the new compilation targets really started emerging. So JavaScript support, which was there even in the pre-1.0 days, has stabilized in 2017 in Kotlin 1.1. And then the same year, Kotlin native appeared for the first time, which was a big landmark. This allows you to compile Kotlin code to native machine code without having to run it in a VM of any sort. And this supports all of the desktop OSs, so Mac OS, Windows, Linux. And really interesting code sharing use case is, of course, between Android and iOS. And Kotlin native also allows you to compile Kotlin to native machine code for iOS. And all of this goes through the LLVM toolchain, so it basically gets compiled the same way as Swift code gets compiled for iOS. Now, for the formats here, I've put up klib, which is our own like intermediary library format, and the kexe format, which is Kotlin executable. But with native compilation, you can produce all of the different native formats that you expect. They just don't fit on the slide. So you can create SOs and DLLs and so on. OK, so now we had 3 platforms. Then we started stabilizing this whole multi-platform story. It went to alpha in 2020. This was the first step of stability. As you can see, there was a strong mobile focus. The technology was branded as Kotlin Multiplatform Mobile at the time because iOS and Android, again, very popular code sharing use case. And at this point, for example, we have stabilized the binary format for Kotlin native builds. So from this point on, we had binary backward compatibility for Kotlin native. Another big milestone was the beta 2 years later. This introduced a new memory model for Kotlin native. Previously, you had to do some special things when compiling to native. When you were accessing objects across different threads, you had to like freeze them and just treat them generally differently than when you were using Kotlin on the JVM. Luckily, with this new memory model, we did away with all of that. So you can write Kotlin code the exact same way for all of your platforms. And then we got to stable at the end of last year. And from this point on, there are very strict compatibility guarantees for the entire Kotlin multi-platform technology, just like there have been for the language itself since the 1.0. But of course, we don't stop at stable. We also have a lot of new things coming up. One of the newest things that has appeared on the scene is support for compiling Kotlin to WebAssembly, which is a really exciting target for the web. All modern browsers already support it. And it also has possibilities of running not just in browsers, but also on server side and so on. So we're also really excited for that new target. With that, we had all of these targets. And just like on the JVM, we do our best to interoperate with all of the native libraries and APIs on each of these targets. Of course, JVM is the smoothest, being the first priority and the first supported platform as well. I want to briefly talk about how all of this actually gets compiled. So how do we go from all those Kotlin source files to the platform-specific outputs? The way that this works is that all Kotlin code starts compiling the exact same way. They go through the front end of the compiler first. Here, I'm showing you the K2 front end, which is our new compiler implementation, which we've just shipped last week with Kotlin 2.0, which is a huge milestone for the language. And this compiler is up to twice as fast in a lot of projects than the previous one was. So in this stage is where all of the parsing happens, type inference, call resolution, and so on. And once we've built the syntax tree and parsed all of our code, we eventually go to different backend compilers, which are able to generate platform-specific outputs as needed, and of course, perform a bunch of platform-specific optimizations as well. So we have this timeline so far for how Kotlin Multiplatform came to be. And there are a lot of other Kotlin stories that you could tell on the same timeline. There's a story here to tell about the language evolution itself, which we're not going to touch on today, about the server-side adoption of Kotlin, about using Kotlin for data analysis and data science. But the story that I want to highlight here, because it's very relevant for multiplatform, is the Android story for Kotlin. This started in 2017 when at Google I/O, on the main keynote, they've announced that Kotlin would be an officially supported language for Android development. This was huge, as from the beginning of the Android platform, Java was really the only supported language, plus C-based native interop capabilities. But essentially, it was Java until then, and now we had Kotlin available as well, officially supported by Google. In the same announcement, Google and JetBrains have founded the Kotlin Foundation together, which has the aim of basically controlling the evolution of the language, making sure that there's no ugly breaking changes in it, and preserving the Kotlin trademark, as well as giving financial support to the ecosystem that exists around Kotlin. So that happened in 2017. As you can see, compared to the 1.0 of the language, this happened very quickly. No one really expected this announcement so soon from Google. But the community has actually been using Kotlin on Android even before Google supported it, actually even before the 1.0 of the language. People were using Kotlin in production for Android because it was such a better language than the Java they had available at the time. 2 years later, Google took the next step with Android development. They went Kotlin first. And from here on out, all of their APIs, documentation, content was generally targeting Kotlin, with Java supported as a secondary language. And in the same year, they've announced Jetpack Compose, which is Android's modern toolkit for UI development, which is also entirely Kotlin. The UI code is written in Kotlin. It integrates with Kotlin on the compiler level as a compiler plugin, again, making really good use of both the language features and the capabilities of the compiler to be extended. And then, even more importantly for us with KMP, around the end of 2022, the first Jetpack libraries, which are initially written for Android, started being converted to multi-platform libraries. So Google has slowly, quietly, in an experimental way, started using and supporting Kotlin Multiplatform. And then, about 2 weeks ago at Google I/O, they took the next step in that, which is that they now officially support Kotlin Multiplatform for sharing business logic between Android applications and applications running on other platforms, which is yet again a huge milestone for us, and we're very grateful, of course, that Google is backing this approach for code sharing. So with all of that history and introduction, let's take a look at how this actually works. Let's say that we want to build an application that will be a client for desktop, iOS, and well, desktop, Android, and iOS use, and we want to share code between these platforms. We need 2 of the compilation targets that we've seen previously. For the desktop and Android targets, we want to be able to compile Kotlin to Java bytecode, and then for iOS, we want to compile to native code and build a framework that we can then integrate into our iOS application. Of course, we don't want to have 2 different sets of Kotlin code for this. We want to have one set of Kotlin source files that we can compile to both of the platforms. And this code, which gets compiled to all of the platforms that are application targets, is what we call common code in the terminology of Kotlin Multiplatform. And besides this, when you're building a Kotlin Multiplatform module, you can also have optional platform-specific source sets next to it, which are able to access the platform-specific APIs on each of the targets that you're using. But of course, generally speaking, you'll want to build most of your things in common code so that you only have to write it once. Then, for compilation, the way that this works is that whenever you're compiling for desktop, it would take all of your common code and those desktop-specific bits, if you need them, and compile those to desktop. For Android, it would take all your common code and the Android specifics, and then the same thing goes for iOS, common and iOS-specific code. Now, in your common code, you can use anything that doesn't depend on the individual platforms that you're using. So you can use all basic features of the language. You can create classes. You can create functions. And all of those things. You can also use things like the Kotlin standard library, which contains collections, a rich set of APIs for working with collections, strings, string extensions, and so on. So all of those things that don't depend on specifics of the platform, you can just write in common code and then compile to all of your targets. On the other hand, there are tasks where you can't write it without depending on platform APIs, like accessing databases or making network calls. And for these cases, we have the expect actual mechanism in Kotlin. With this, you can create a declaration in your common code of what you expect to exist in your application, and then you can implement that individually on each platform. Let's take a look at an example of this. Let's say that in our common code, we want to have a getPlatform function, which simply returns a string here describing the platform that we're running on. Then on the desktop target, we could create an actual function with the same signature, which is basically the implementation that will be swapped in at compile time when you're compiling for desktop here. And in the case of desktop, we could use the JVM system class and grab the version of the JVM we're running on. Similarly, on Android, we would create an implementation for this function. Here, we can again use an Android-specific API like the build class, which contains information about the manufacturer and the specific type of our device, as well as the Android version, and we could use that to construct the platform string. And we could do the same thing on iOS. We could grab an iOS-specific API like UI device and use that to read the iOS version of our device. And this last one should surprise you, because here, because in the desktop and Android cases, we were calling into JVM APIs, which is pretty trivial when you're using Kotlin. But in the case of iOS, we're actually calling into an API here, which is designed for use from Objective-C and from Swift. But through Kotlin native, all of these things are mapped out to you in Kotlin code automatically, all of the built-in capabilities of the platform, so you can very easily access APIs such as UI device, even from your Kotlin code. Now, you don't want to do this kind of mapping every time that you encounter something that requires access to platform resources. So we luckily have a great ecosystem of multi-platform libraries to support you along the way as well, which have been growing very steadily in the last couple of years. And we now have these for most common scenarios that you would think of. But again, if you do have to bridge out with expect actuals, that's also pretty easy to do in your own application. So with a multi-platform library, taking a look at just one here real quick, and then we'll get back to a bunch of others later on. Here, for the sake of the example, I've imported the Ktor library, which is our very own networking library for Kotlin, both for the server and client side. And of course, it makes great use of all of Kotlin's capabilities, and it's a multi-platform library. So if you import a multi-platform library like this, you can actually use it in your common code. You can create an HTTP client instance. You can make API calls and so on. And it's the library that will handle all of the platform-specific details of how you can actually execute a network call for you. And it abstracts away all of those details. So that's roughly how you assemble Kotlin Multiplatform module. And once you have built up this shared code that you want to put in your applications, you can build actual applications on top of it. Going back to our example, we're building a desktop, an Android, and an iOS app on top of it. As you can see here, besides this shared logic that you have as the basis for your application, you can still have your own native logic in each of your applications written in the native language of the platform. And you can also have UI implementations in whatever is the default for the platform. And something really cool about Kotlin Multiplatform is that you get to choose what goes into this shared logic. If you want, you can start out with a very thin shared layer. You can share one function for a start, like some critical calculation that always has to be right across all of your apps. Or you can share one module or one class implementation. A very popular thing to start with is analytics, where you want to make sure that you're using the same keys across all of your platforms when you're logging events to the server side. You've just seen a multi-platform networking library, so obviously that's pretty easy to build with KMP. Then, over time, you can, of course, also go the other way. You can strive to minimize the application-specific logic that you have duplicated or, well, however many apps you have. Across all of your platforms, and you can try pushing all of those things into shared code incrementally. But you can do this incrementally, and it's up to you where you place all of your code, which also makes it really easy to get started with KMP in an existing application. Now, what we still have duplicated here across the board is the UI implementation. And if you want, you can also share UI using Kotlin Multiplatform. And the solution for that is Compose Multiplatform. I've previously mentioned that Android's current UI toolkit is Jetpack Compose, built by Google. Compose Multiplatform is a project by JetBrains built on top of Jetpack Compose and extending it to multiple platforms. So you can generally take the same APIs that you have for Android UI development and reuse it for different targets. Here's the specific targets that are supported. On Android, using Compose Multiplatform is just the exact same as using Jetpack Compose, so that's a pretty boring use case as far as that goes. On desktop, Compose Multiplatform runs on top of the JVM, and it has been stable for a good while. And then for iOS and web, we are currently stabilizing Compose Multiplatform. We've had great improvements here over the last year. On iOS, we've improved things like native scroll physics, text input handling, a lot of things around accessibility. And then on the web, where we are primarily using WASM for Compose, we have improved screen handling, different screen sizes and densities, pointer and keyboard input, and a lot of performance improvements happened over the last year, which is how we got to the beta and alpha versions, respectively, just last week for both of these platforms. So if you've ever seen Jetpack Compose for Android, this is roughly what the UI code looks like. So you're building this all in Kotlin. It's declarative, it's reactive, and you have great state handling and theming capabilities in there. And the only difference, again, between Jetpack Compose and Compose Multiplatform is that instead of writing this just for Android, you can now write this code and place it into your common Kotlin sources, and you can compile and run it across different targets. Otherwise, the APIs are essentially identical. You can use almost all Android learning resources for Jetpack Compose with Compose Multiplatform, including all of Google's documentation, and so on. So with Compose Multiplatform, if we want, we can replace our individual UI implementations now with a shared UI written in Compose Multiplatform. But of course, this is also not an all-or-nothing proposition. You don't have to decide to have shared UI for all of your apps. You can still interoperate with the native UI toolkits of each of the platforms that are supported. So you can mix this with Swing UI, for example, on desktop. You can mix it with Android views on Android. And you can mix it arbitrarily with Swift UI and UIKit on iOS. Now, while we have this slide up, I want to focus on one thing here, which is that if you look at this stack from the perspective of the Android application, this is a very, very boring and standard stack as far as Android is concerned, right? We're writing Kotlin code. We have UI and Compose. All of these things are the standard ways of development for Android these days and recommended by Google. So this is one of the superpowers of Kotlin Multiplatform, if you will, that as far as Android goes, you're not using any extra exciting technology. You're using the completely default stack of things for your Android application, which no other cross-platform solution is able to claim. Also, this means that should you want to quickly build a greenfield project and get your product out into the stores, you can do all of it with basically 100% shared Kotlin code from business logic to UI. And if you later on choose to go to native UI on iOS, for example, because you just want a very, very native experience and a polished experience, it's pretty easy to pivot from having fully shared Kotlin code to adding some Swift UI. And again, you can do that incrementally as well. Here are some examples of mixing Swift UI with Compose, just as a quick showcase. So on the first screen that we can see here, that's a screen generally written in Compose, but then we have an Apple map view integrated in it. On the second screen, we kind of have the opposite, where we have a full screen camera view, which is a native view, and then we're drawing a bunch of buttons on top of it using Compose. And then on the third screen, we have a complete mix again. The top toolbar and the bottom navigation are all Swift UI. This input field for the chat view here is also Swift UI, but the rest of the chat with the bubbles and the background is a Compose view embedded behind it. So you can really arbitrarily combine Compose and Swift UI in your application, not just on the screen level, but also within individual screens, should you need to. Now, some recent improvements from Compose Multiplatform while we are here. We have earlier this year introduced a resource API, which allows you to share things like localized strings or image assets between your different platforms. And we are also continuously working on bringing more and more originally Android libraries to Kotlin Multiplatform, such as the lifecycle view model and navigation libraries, which have been recently added. View model, for example, again, if you've seen Android before, is a state holder that helps you organize your code around the UI layer. And for Kotlin Multiplatform, you now have the exact same view model class available. And it even goes as far as being in the exact same package as the original Android view model, as you can see here. And the same goes for things like navigation. Jetpack Compose has an official navigation library on Android, and that's now also available to use with Kotlin Multiplatform with multi-platform APIs, which works across all of the supported Compose targets. But these are not the only options. Again, we have this rich ecosystem. And at this point, I want to take a bit of a look at the ecosystem that we have so that you have some idea of what's already available there. So first of all, we have networking libraries. I've already talked about Ktor, which is our very own networking library, again, for both server and client side. And we also have libraries like the KTorFit library from the community, which is a higher level networking library going kind of from the HTTP level to the REST level and giving you something like Retrofit is doing on Android. We also have a lot of data storage options. We've had SQLite and KStore for a while, so these offer structured storage and just object storage into files. And then the Room library, which is, again, originally an Android library and is based on SQL, has also been released just a couple weeks ago for multi-platform use. We also have key value storage options. Again, Google is here with Data Store. They have released that almost 2 years ago now for multi-platform use. And we also have community libraries like multi-platform settings. We have a lot of different solutions for dependency injection. We have these 3 major players and more. And all of these offer really nice solutions that work across all of the Kotlin multi-platform targets. We also have navigation libraries. We have the official one, which is based on Jetpack navigation. But as I've already mentioned, we also have community ones that you can choose if you prefer the style that they are using. We also have image loading supported. Getting back to the UI, here we've had 2 significant players pretty early on, Compose Image Loader and Camel. And the Coil library, which, once again, this is a very common theme here. This was originally an Android library written fully in Kotlin, has also been recently ported to support Compose Multiplatform. I also want to touch for a moment here on theming. So by default, Compose Multiplatform ships with the same material theme that Google ships with Jetpack Compose for Android. So all of those material components are available when you're using Compose Multiplatform. But there are also community themes, such as this one, which aims to mimic the iOS-style widgets using Compose. And you can, of course, always build your own themes as well to fit your branding and application needs on the foundation layer of Compose. So that's a very quick whirlwind tour of some libraries that are available, just to give you some idea of it. One of my colleagues maintains this repository of awesome Kotlin multi-platform libraries. As you can see just from the categories here, there's a lot more in there. We have solutions for testing, for analytics, a bunch of more UI libraries, and so on. So whenever you're looking for a multi-platform solution for something that requires platform specifics, then this repository is a great place to start. All right. I do have to talk about tooling a bit. It is a JetBrains talk, after all. So of course, we also offer great tooling for working with Kotlin Multiplatform. And the place where we offer that tooling is in Fleet, which is a powerful code editor, and it's one of our latest products. One of the interesting things about Fleet is that when you first start it, it opens as a simple, lightweight code editor, so you can navigate your code, you get some basic syntax highlighting, and things like that. Then you can turn on what we call its smart mode, at which point Fleet takes a look at your project, the languages that you use in there, and loads the appropriate language servers and code engines to support working with those languages and frameworks. For example, in the case of Kotlin, this would load IntelliJ as a backend service to power things like code completion, refactoring, and more. And all of this is built in a distributed way, which means that you can run all of this not just on one machine, but you can also run your Fleet workspace with your code, with these language servers, with compilation happening on one machine, and you can connect to it with a remote machine if you want. For example, you may run this on a VM in the cloud somewhere, or you might run it on a powerful Office PC that you have, and then you can connect to it remotely with a less powerful machine as long as you have a good internet connection. And of course, it's not just you who can connect to it. It's also really easy to start a session and just share a link with your colleagues so that you can all join the same workspace and you have all the same UI and tools available on all of these different clients because of the inherently distributed architecture of Fleet. Because Fleet loads language support dynamically, it's a multi-language polyglot IDE. It supports a lot of languages. This is just some highlights of the supported ones. And of course, for Kotlin Multiplatform here, the ones on the right-hand side here are the most exciting. So Kotlin and Swift support is really handy when you're working on a project that's sharing Kotlin code with iOS. To get started with Fleet, you would go to JetBrains Toolbox and install it from there, where you can, of course, also find, hopefully, all your favorite other IDEs. And while we're here, JetBrains Toolbox is actually a Compose Multiplatform application for desktop. So we have at least 1 million users for Compose already, just through Toolbox itself. Moving on, once you have Fleet up and running, you can grab a project, you can drop it in there, and it will, again, start smart mode. It will analyze your project and load the necessary language support. With a Kotlin Multiplatform project, you can also see that this pre-flight window pops up, which makes sure that you have the correct environment configured to work with a KMP project. It will check that you have a JDK set up, that you have the Android SDK and Xcode build tools configured. And if anything goes wrong, it will give you helpful suggestions on what you should look at fixing. Then, of course, you can work with both Swift and Kotlin files. So Fleet fully understands Swift code and Xcode projects, so things like refactoring work in Fleet in Swift files, as you would expect. And not only does that work in Swift, it also works across languages, because Fleet understands both Kotlin and Swift, as well as many other languages. So for example, as you saw here, you can navigate from a Swift file into Kotlin code when you're calling across languages. And whenever you use something like refactoring, that also works across languages. We'll find usages in both languages and rename all of them correctly. You can also, of course, run your applications straight from Fleet, but not only can you run them, you can also debug them straight from Fleet. You saw here real quick that you also had device selectors for both iOS and Android applications that you want to run. And once you're debugging, you can easily step between the two languages. You can place breakpoints in both. And as you're stepping through these breakpoints, you can progress between Swift and Kotlin source files seamlessly. Now, not only do we have KMP support, we, of course, have really great Compose tooling support in Fleet as well. So, for example, you get previews for the composable code that you're writing so that you can take a look at the UI right there in the IDE without running the application. And we also have support for things like Compose resources. So you can edit those files. Fleet will realize that you've edited the files, regenerate the necessary accessors, and update your previews for you automatically. And no IDE is complete these days without AI support. So, of course, JetBrains AI Assistant is also available within Fleet. And thanks to the language support, you can use it not just with Kotlin, but also you can use it to generate some Swift code as well. So, getting into the summary here, so Kotlin Multiplatform is already stable and production ready. It has been stable officially since last November. It can give you the best of native and cross-platform solutions. You can choose very flexibly what you want to share and what you want to keep on the native side of your applications. And naturally, you get all of the great JetBrains tooling that you expect to have with Kotlin. To have a closer look at Kotlin Multiplatform, we have a bunch of official samples that you can find on this link so that you can grab those projects and explore them for yourself. As you can see, we have applications of a bunch of different styles implemented with KMP for you. And if you want to start a new project, we have a Kotlin Multiplatform wizard for that, which you can find at kmp.jetbrains.com. This has selectors for which platforms you want to include in your project. Again, you have a choice. You can choose, for example, under iOS, whether you want to share UI or you want to have a native UI implementation. And within the same wizard, we also have some more complete, prepared sample projects for you that you can take a look at as templates and then go on from there. With that, thank you very much for your attention today. Here are some more links to learn more about Kotlin Multiplatform, Compose Multiplatform, and of course, Fleet. And if you have any questions, hopefully you've already sent them into Slido. Thank you.
Thank you, Marty. Great presentation. Yeah, we have already 2 questions on Slido. So first of all, multi-platform frameworks tend to omit 3D rendered. Does this framework support such functionality?
So I take this as, do we have 3D rendering within KMP? We don't have general 3D rendering with Compose. We are using Skia to draw on basically a canvas for you. But we don't specifically have 3D capabilities, although it depends on what exactly you mean by 3D. So if you find me after the talk, I'm happy to hear more about your use case.
OK, and the other question, how is the developer experience on Windows? I guess via Fleet's remote machines, you should even be able to develop for iOS, right?
Yes, so with all of the iOS targets here, we of course have limitations because with all of the iOS toolchain with Xcode build tools, all of that is tied to macOS, as in by Apple. You can only compile anything for iOS or macOS on Apple machines. But you can connect with a Windows machine to your macOS machine and edit Swift code using Fleet. Obviously, the best Swift experience is always going to be on macOS because of just Apple's limitations. But we definitely hear this use case, and it's something that we want to make pretty nice.
So you did answer what iOS engineers think about Kotlin in general. OK, cross-multi-platform tools often tend to lag behind native platforms when they introduce new features. How KMP deals with this?
OK, sure. So generally speaking, you get pretty immediate access to new features as you can just call into the native APIs on each platform. I guess libraries would have to catch up to support it for you in a multi-platform way automatically. But if you're implementing your own platform features with expect actuals and things like that, then there's nothing preventing you from using something that's, for example, a new iOS API from day 1 of the new OS version.
And the $1 million question, is it free?
Is what free?
Kotlin in general, I guess.
Kotlin is free and open source. Kotlin Multiplatform and Compose Multiplatform are free and open source. Fleet is currently in a public preview where it is free. And then we'll eventually have a pricing model for it, which is TBD. But if you take a look at our website for Fleet, there are some ideas of what the pricing might look like. It will probably possibly be free for non-commercial use and then paid for commercial use. But take a look at the website. And again, everything there is preliminary.
OK, any other questions via Slido? I have nothing. No, so I would like to give you a small gift, although you are Hungarian, so maybe you won't value that so much as our international presenters, but still, another round of applause for Marty.
Thank you.